Welcome back. In the last video, I said that we were going to next create a cumulative frequency polygon. So that's what we're going to go ahead and jump into right now. Remember, a cumulative frequency refers to the sum of frequencies for each of the subsequent classes that we see. Okay. So in that previous example, we were given a frequency distribution table that had some number of classes. Let's go ahead and count them. 1, 2, 3, 4, 5, 6, 7 classes. Okay. Now, what I mean by the cumulative frequency counts the sum of frequencies for each subsequent class, I mean that you will need to reorganize your frequency table so that each row, as we go down the table, represents the number of data values that are below the upper class boundary. Okay. So what I've done here is next to the class boundaries column, I created a column that I labeled UB for the upper class boundary. And I have labeled these rows as less than 104. In other words, I've changed the nature or the description here so that now this row is going to be tallying up or counting up how many data values fall below the upper class boundary here, which is 104. So how many data values were less than 104.5? That was 2 data values. Okay. In the previous frequency distribution table, the class boundaries 104.5 and 109.5 contained 8 data values. So in this cumulative frequency distribution table, the next row will be labeled as all of the data values that are less than this upper boundary here, which is 109.5. And if we had 2 in the first class, a frequency of 2 in the first class, and a frequency of 8 in the second class of our original table, then if you add those together, then we should be getting 10. So we're just adding up the class frequency before this class that we're working in right now, which is the second row. Okay. So once you do that and add up every class frequency, which is below the class that you're working in, you should eventually get to the final class down here, which has the sum of all the frequencies. Okay. So the cumulative frequency is counting up or adding up all of the frequencies from the previous classes. So at the very end, the cumulative frequency table should indicate for the final class that the final class is counting the entire sample size. In other words, the total of all the frequencies. So once we have that frequency table set up, that cumulative frequency table, we can jump into an example of constructing a cumulative frequency polygon. So let's go ahead and jump into the homework platform and take a look at a sample problem. Okay, get ready. All right, so this problem says we have the cost of utilities. The frequency distribution represents the cost in cents for the utilities of states that supply much of their own power. Construct an ogive for this distribution. So that's one thing that I failed to mention, but it's worth noting that some homework platforms, some different textbooks might refer to a cumulative frequency table or a cumulative frequency polygon rather as an ogive. That's just a different name for the same idea, okay? So what we're gonna do here is take a look at the frequency distribution table that we were given. Now we have the class boundaries from 4.5 to 8.5, and there is a frequency of 12. That means that 12 of the data values from the raw data, which we don't see here, fell between these two values, 4.5 and 8.5. Okay. So to translate this to a cumulative frequency table with 7 classes, if we look below here, we see 1, 2, 3, 4, 5, 6, 7, 8 columns. Okay, we need to be very careful and cautious when we are interpreting this. So be very mindful of this first column, or this first row rather, that says how many data points or how many data values are less than 4.5. Okay. How many data values are a value of less than 4.5? So now if we look at the original frequency distribution up here, this first class indicates that 12 data values fall between 4.5 and 8.5. That means that we don't have anything in our data set that is below 4.5. So this first row, the cumulative frequency, should be 0. But the next row says how many data values are less than 8.5. And since 8.5 is the upper boundary of our first class, then all 12 of these values, which are indicated by this frequency of 12, have to fall below this class upper boundary. So we're going to put 12 right here. And now, just like I explained previously, we can sort of get started with this process of adding up our cumulative frequencies, okay? Because the next class indicates that there are 15 additional data values between 8.5 and 12.5. So when we look at the cumulative frequency table, this says how many data values are less than 12.5? Well, if I know that these 15 data values are below this upper boundary, which is 12.5, that also implies that these 12 data points here that are indicated in the previous class are also values below 12.5. And that's why we're adding them up with the 15. So we'll go down to our frequency distribution table, the cumulative frequency distribution table, sorry. And we will just simply take this 12, add our 15. In other words, we'll add these two up, and we should get 27. Okay? So we'll type that in, 27. You can always double check in your calculator. 12 plus 15 should be that 27, and we're good to go. We're then going to continue this process of simply adding up our frequencies. So we have 15 here. We're going to add an additional 4. So really, we're going to take this 27 and then add that additional 4, those 4 additional data values that are below 16.5. Okay, so 27 plus 4 should give us 31. Okay. Then we can continue on. We have 31, and we need to find the additional data values that are below or less than 20.5. So we go up here, and we'll add these additional 2 data points here, which can add 2 data points to that. So we should be entering 33 here. Okay, that's taken care of. Then we're going to add an additional 1 to that, plus 1. We can indicate that we're going to add an additional 1 there. We'll add an additional 1 there. And then finally, there's no values here between 28.5 and 32.5. So we will add nothing to that final row right there. Okay, so we'll go ahead and fill these in. I wanted to go ahead and have those written out first. So this next one should be 34. This should be 35. And then we add nothing to the last row. So that should stay 35. Okay. Another way that you can check yourself before you wreck yourself is just to simply add up the frequencies and make sure that the total of all these frequencies do sum to make this final row of your cumulative frequency distribution table. So I'm going to clear all of this mess that we have here, and then double check in my calculator that the frequencies do sum to make that 35. So 12 plus 15 plus 4 plus 2 plus 1 plus 1 plus 0 equals 35. So looks like we're on track to get this one correct. Let's go ahead and let go and let God. Check our answer. And sure enough, we got that green check mark. We can move on to part 2 of this question. Now, part 2 of this question is taking this cumulative frequency table that we've constructed and making the polygon. So if we scroll down, we can see construct an ogive for the distribution. In other words, construct a cumulative frequency polygon. Okay, so for that cumulative frequency polygon, we have on our x-axis a bunch of values that are 4.5, 8.5, and so on. We can see here that that pretty much corresponds to these values there in our cumulative frequency table. So we can just transcribe those over in this list of values for our x-axis. So how many data values are below 4.5? We had 0 there. The data values below 8.5 is 12, below 12.5 is 27. So let's just go ahead and put those in. 12, 27. Looks like we have 31, 33, 34, 31, 33, 34, and then we have 35 and 35. Okay. So that pretty much is going to complete our frequency distribution table. Sorry, our cumulative frequency distribution table and our ogive or cumulative frequency polygon. Notice a few things about this polygon compared to the simple frequency polygon. This cumulative frequency polygon is only anchored to the x-axis on the left side, because as you add up more values of frequencies, you should end up with something that is floating above the x-axis. The right-hand side is not going to be anchored at 0 because we're adding up a bunch of things, so we should be totaling up more than 0. So again, one key distinction here between the ogive / cumulative frequency polygon and the simple frequency polygon is that we're only anchoring this on the left-hand side. Okay, so we can go ahead and check our answer now, and we should get that green check mark, which we love to see, and that will complete the example. Okay, so hopefully you guys find this video helpful in understanding what a cumulative frequency polygon is and understanding how to construct it for your homework.